Okay, so in this video, I am going to be talking about arc length and area of a sector as they relate to circles. The things that this video will cover are what is an arc, what is a sector, how to find arc length, and how to find area of a sector. So let's get started. Before we talk about how to find arc length and area of a sector, it's important that you understand what those mean. So on the screen is a circle. Inside that circle, you have the center, and from that center, you have two radii that have been drawn. You can see that it creates this pie slice or pizza slice, however you want to envision it. Now, what is highlighted in orange is what we call an arc. Think of an arc as the crust. If this were a slice of pizza, the arc would represent the crust. The slice, or the area that's highlighted in green, is what we would refer to as a sector. It's the entire area of the rest of the slice. The other important piece that you'll need to know is what is in red. And I've used the theta symbol to just represent that angle can be any angle. But the name of that angle is what we call a central angle. It's called central angle because it's at the center of the circle. And so before we talk about how to find arc length and area of a sector, it's important for you to understand what the parts are and what you are finding more than just what the formula is. So again, the arc of a circle is the crust or the distance of the outside. Area of a sector represents the area of a section of the circle. And then what part of what you'll need to know to find those pieces is what the central angle is. So now let's talk about how to find arc length. So you can see there's a circle and it has a radius of 8 feet and an angle, I'm looking at the shaded area, a central angle of 150 degrees. So what we're going to do is we're going to find arc length. And what that means is we are going to find the distance from point A to point B along the shaded area. Now, arc length has a formula. And arc length, the formula is the angle out of 360 degrees times 2 pi r. Now, before I do this problem, let's talk about what it means. Hopefully, you recognize that 2 pi r is the formula for circumference of a circle. And so when you think about the distance, or to travel from A to B along the outside of the circle, that is along the circumference. Now, what's important to notice is that from A to B, if I follow the shaded area, it's not the full circumference. I'm not going all the way around the circle. Instead, it's a section, or it's just a fraction of the circumference. And that's where the central angle comes into play. That fraction, which is the central angle over 360 degrees, that tells us what fraction of the circumference we are trying to find. Obviously, from A to B is not all the way around the circle, so it's not the entire circumference. So the question we are trying to answer is, what fraction of the circumference is it to go from A to B along the shaded area? So I'm going to go ahead and plug in what we know. Well, we know that the central angle is 150 degrees. So I can plug in 150 over 360 times, I have 2 times pi, and we know the radius is 8. And now it just becomes a matter of solving and reducing the answer as far as we can. So I'm going to go ahead and reduce 150 out of 360. or over 360. So I can divide by 10, which gives me 15 over 36. I can divide by 3, which gives me 5 over 12. And that's as far as we can reduce it. So this fraction becomes 5 out of 12, or over 12. And then we have 2 pi times 8 is 16 pi. And now I can go ahead and multiply those together. So when I have a fraction times a whole number, I'm going to turn the whole number into a fraction, and that just allows me to have the visual of multiplying two fractions. Because to multiply two fractions, all I need to do is multiply the top times the top and the bottom times the bottom. So on top, I will have 5 times 16 pi over 12 times 1. And then we'll just go through and simplify this. So this would be 70 pi over 12. I can reduce, let's divide by 2, so we get 35 pi over 6. And that's about as far as we can reduce. And so I'm going to leave the answer as 35 pi over 6. Now, of course, you can always change it into a decimal by doing the multiplication, 35 times pi, about 3.14, and then divide that number by 6, and you can get that. For the sake of this video, I'm just going to leave it as a fraction, or I'm going to leave it in terms of pi. And so that is arc length. Remember that arc length is just a fraction, or it's just a piece of the circumference. So we just take the central angle out of 360 degrees and multiply that by the circumference, which is 2 pi r. Let's go over area of a sector. Now, area of a sector is a little bit different, but it's the same idea. Remember that a sector, in this case, for this example on the screen, would be the area of the entire shaded region. So what is that area? Now, you'll notice that the shaded area is not the area of the entire circle. It's a fraction of the area, or it's a piece of the entire area of the circle, but it's not the entire area. So when you do area of a sector, it's actually very similar in the sense of we still need the central angle out of 360 degrees, because that tells us what fraction we're going to take. But where it gets different is we are not multiplying by 2 pi r, that's circumference. Instead, we want a fraction, or we want to know what piece is that shaded area of the total area. And so we can go ahead and fill it in. This would be 150, that's the central angle, divided by 360 degrees, times pi, and the radius is 8 squared. Now, I already know what's great about doing area of a sector and arc length for the same problem is the fraction is exactly the same. So I've already reduced 150 over 360. I've already reduced this to 5 over 12. So I don't have to do that work again. It's the same fraction. Now 8 squared is 64, so this is 64 pi. And now I can just multiply. And so same idea, right? If I turn 64 into a fraction, then I could multiply across. So I do 64. This would be 64 pi times 5. And then on the bottom would be 12 times 1. And so 64 times 5 is 320 pi, divided by 12 times 1 is 12. And then I can just go ahead and start simplifying. So doing this in my head, so we divide by 2, that would give us 160 pi over 6. I can divide by 2 again, that gives me 80 pi over 3. And that's about as far as we can reduce it. So I'll leave my answer in terms of pi. So our final answer, or the distance, the area, not the distance, the area of that shaded region is 80 pi over 3. Now, just like arc length, you can plug that into your calculator if you need your answer in decimal form, but that is how you find area of a sector. Again, it's very similar to arc length, except it's not a fraction of circumference, it's a fraction of the area. So that'll be it for today's video. We talked about what is a arc, what is a sector, how to find arc length, and how to find area of a sector.